Hello guys, welcome to our channel, Raw and Basic. So this time our video will be about computing your periodic payment of an ordinary annuity. So to get the definition of your ordinary annuity and the definition of your periodic payments, please watch my other videos about annuity. But this time we will be computing your periodic payment. So periodic payment is also known as your regular payment. Okay? The regular payment. So giving you the idea of annuity. Annuity is you loan certain amount or certain item and you will be paying it in regular basis, or shall we say in terms of installments. So for us to learn it more, let us answer this situation, and we have our problem on the board. Paul borrowed 100,000 pesos. He agrees to pay the principal plus interest by paying an equal amount of money each year for 3 years. What should be his annual payment if interest is 8% compounded annually? So, on our situation, it is very evident that this situation is about ordinary annuity because he will be paying annually, or the compounding frequency of interest is compounded annually, and he will pay every year. So annually means every year. Okay? So the interest is compounded annually, as well as he will be paying a certain amount of money every year. So they are equal. Therefore, it is an ordinary annuity. So before we can solve for this problem, we have here formulas on the board. So this is the formula first. This is the formula in computing your future or maturity value of ordinary annuity. So from here, we have derived R, which is your periodic or regular payment that we will be trying to solve. So F is equal to R times the quotient of the quantity of 1 plus j raised to n minus 1 over j. And R is equal, from here, R is equal to F times j divided by the quantity of 1 plus j raised to n minus 1. Okay? So this will be our formula in computing your periodic or regular payment again when the future value or maturity value is given. Then we have P is equal to R times the quotient of 1 minus the quantity of 1 plus j raised to negative n divided by j. So from here we have derived R equals to P times j over 1 minus the quantity of 1 plus j raised to negative n. So this will be our equation or formula when the present value or the principal is given. So analyzing our problem, so what it is all about. So let us focus on here. We have 100,000. So we will choose what equation or formula between these two that shall be used. Okay, so we have Paul borrowed 100,000. So 100,000 will be our, okay, so 100,000 will be our principal. Okay, so we will use this equation. Okay? So I will erase this one for us to solve. So take note that we will be using this equation. Okay, so let us first identify the given data from our situation. So we have 100,000 is our principal or present value. So we have 100,000. Okay? Then by paying an amount of money each year for our term will be, or time is 3 years. Okay? Then what should be this annual payment if the interest is, so our rate is 8%. Okay? Converting it into decimal, we have 0.08. Right? Then we have M, our frequency of conversion or compounding frequency. So annually, of course, you will be paying once every year, compounded annually. So again, you will be paying once every year, and as well as the interest is compounding once a year. Okay? So our requirement here, of course, we will be solving for your R. So R denotes your regular or periodic payment. So periodic because it is fixed for you to pay in each period of your annuity. Okay, for our solution, so the equation for us is R is equal to this thing. We have P times J divided by 1 minus the quantity of 1 plus J raised to negative N. Okay? So first, let us try to solve J and N. So J is equal to R over M. Okay? Then J is equal to R, which is 0.08 over M, which is 1. Then J is equal to 0.08 divided by 1. So this is the identity property of division. Any number divided by 1 is equal to that number. So we have 0.08. Okay, then let us solve for N. So N is equal to the number of payments. That will be N times T. So N is equal to, our M is equal to 1, and T is equal to 3. So therefore, 1 times 3 is 3. Again, this is the identity property of multiplication. Any number multiplied to 1 is equal to that number. Except 0. Okay? So let us now what do you call this? Substitute the value of our given. We have P is equal to 100,000. Right? Times, we have J is equal to, our J is quantity 0.08 over 1 minus the quantity of 1 plus, again, our J is 0.08 raised to negative N is equal to 3. Okay, using your calculators, you want, of course, this start, solve it manually, so use your calculators. So you will have this one. You'll have 38,083.35. Okay? Again, we are rounding off numbers just like this one, because on this context, this figure is money. And speaking about money, we are rounding off the figures or value into 2 decimal places to the right of your decimal point, or shall we say, this is 38,803,035 cents. And for our conclusion, to answer the question of the problem, what will be his annual payment? So his annual payment, therefore, Paul should pay 38,803.35 every year for 3 years. Okay? So if you have seen some errors or if you have some suggestions, kindly write it on our comment section. Okay, so I will give you another example. In computing your periodic or regular payment of ordinary annuity, because this first example is all about using this equation when P is given. So on the other example, I will present a situation or problem where your future value is given. Okay? Okay, for our second example, we have here on the board, Mr. Bean would like to save 500,000 for his son's college education. And how much should he deposit in a savings account every 6 months? If every 6 months for 12 years, if interest is at 1% compounded semi-annually. So again, on our problem, it is evident that we are computing about ordinary annuity. Because if you have seen this one, compounded semi-annually. Semi-annually means every half of each year. Semi means half. So half of the year is 6 months. And he will be paying every 6 months. So again, the compounding frequency and the frequency of payment is, or they are equal. Okay, so let's proceed to the steps. First, we should identify the given. So we have 500,000, and that will be your F. F is equal to 500,000. Okay? Then we have M is equal to 2. 2 because he will be paying twice a year. Because we have compounded semi-annually. Either you will get the value of M because they are equal, so either you can have this one every 6 months, so equal to 2. Every 6 months means twice a year, or shall we say compounded semi-annually, so twice a year. So it's up to you where to find the value of M because they are again equal. So R is equal to 1%. Okay? Then our P time or term of this entity is 12. Right? Okay, so our required is computing your R or your periodic payment. So R denotes regular payment. So regular payment is also known as periodic payment. Okay? Then let's proceed to your solution. So we have R equals to F times J over 1 plus J raised to n minus 1. Okay? So let's write it in here. So before substituting, let us first solve for j. So j again is equal to r over m. So r is equal to 1%, or shall we say r is equal to 0.01 in decimals. So we shall have j is equal to 0.01 over m, which is 2. So therefore, j is equal to 0.005. Okay, please check using your calculators. Then we have to solve for n first. So n is equal to m times t. So n is equal to m, that is 2, and t is equal to 12. So therefore, n is equal to 24. Okay? Now we can substitute to this equation. So r is equal to f. So where's your f? F is equal to 500,000, right? Times j here, 0.005 over this one. 1 plus j. So j again is 0.005 raised to n, which is equal to 24, minus 1. Okay? So we have r is equal to the quantity of 500,000, or 500,000 times 0.005 over the quantity of 1 plus 0.005 raised to 24 minus 1. So computing using your calculators, we can have r is equal to this figure. Again, we are speaking about money. So again, we will be rounding it off to 2 decimal places to the right of your decimal point, or shall we say on the hundredths place. So for our conclusion, therefore, Mr. B should deposit 19,660 pesos and 31 centavos every 6 months for 12 years. So it's up to you and how you should answer the question of the problem, or how you should state your conclusion, as long as it will answer the problem of the situation. So the problem is all about how much should he deposit in a savings account every 6 months. So after computing, we come up with 19,660. Therefore, Mr. Bean should deposit 19,660 pesos and 31 cents every 6 months for 12 years. So I guess that you have learned something from this video. Please subscribe and thank you for watching.